And hello, welcome to this video. So in this video, we are going to try and solve the the problem with this injection thing. So we are saying that dependency injection must occur the moment the object is created. Otherwise, you run into this error. Okay. So how are we supposed to do it? Okay. So we need a function that executes the moment, or we need a function or method that executes the moment that we make an object. Okay. The function or method must execute the moment we create the object. So there's a special kind of function for that. So all these functions normally, you have to manually invoke them. You have to manually call them or ask them to work, so to speak. So for example, if we have this burger.inject, okay, we are telling C#, please start this function called inject, or please start this function called cost for this case here. Okay, a constructor is a special function that executes automatically the moment you declare an object. So why is it called constructor? Because it constructs some of the, part of the reason it's called that is because it constructs all the basic variables and dependencies you need. So the best place to do dependency injection is to do it straight away when the object is created. Okay, so dependency injection must occur the moment the object is created. So we need a special function that executes the moment the object is created, and these functions are called constructors. Okay, so let's write this down here. Constructors are special functions or methods which execute the moment. Okay, execute the moment an object is created. So this is a very important concept. So we are going to make use of a constructor. How do we declare the constructor? Okay, to declare a constructor, very simple. Of course, we use public. Okay, public and then something. So how do we define a constructor? Constructor, you need to name the function like this. Okay, so if your class is chicken burger, the constructor will be called chicken burger. Alright, and then it will take in some inputs, and then it will take in some outputs. So this is what the constructor looks like. Okay, the constructor looks like this. And how do we ask the constructor to handle the dependency injection? So we ask it like this. So okay, patty, buns, and other. Okay, because patty, buns, and other, these are classes, and then patty, buns, and other, these are the objects. So now we are going to copy and paste this here. So this will actually also do dependency injection, and instead of doing it with a manual function like this, we will use the constructor. Okay, we will use the constructor. So this object creation must occur after we make our dependencies here. So let's do constructor injection like this. Patty, buns, other. Okay, of course this thing we can leave it here, but it's kind of redundant. Okay, but this should work properly. So now the thing's working. Okay, and then we have now the chicken burger costs this much. So we have successfully used a constructor to help us inject all our dependencies. Okay, now I said about the dependency thing is that it should be, in theory, very easy for us to swap out dependencies without ever touching this code here, right? Okay, we should be able to swap out dependencies without ever touching this chicken burger code here. Okay, let's test that theory out. So I have a mock other object, and this should be inside the other object here. And let me try putting this in, and then you will see that we run into an error. Mock other. Okay, I save it, and then we will have a we have a problem here. It says argument 3 cannot convert from .NET test models mock other to other. Okay, so you can see that there is a problem. Okay, this mock other and other class, they are two completely different classes. You cannot use an object created for the mock other class and use it to replace an object that is supposed to be an other class. So there seems to be a problem. Okay, because these two classes are not interchangeable. Okay, these two classes are not interchangeable. Okay, how do you make it such that they are so-called how do you make it such that if I want to replace this dependency here, other with mock other, I can just do it by changing one keyword. Okay, how do you do that? Okay, so I want to introduce to you the idea of interfaces. Okay, interfaces. Okay, C# interfaces. So interfaces help you to so-called define the behavior of multiple types. And why is it called interfaces? Well, let's use GIMP again, and and let's just draw some diagrams to help illustrate what's going on. So we have our chicken burger class. Our chicken burger. We have our chicken burger class right here, and it's dependent on what dependencies? Well, we have a buns dependencies, or petty dependencies. We have a petty dependency, right? Okay, so the petty dependency, you can either inject in the mock petty, or you're supposed to do it like that. You either have a mock petty class object, you have an object created using the mock petty class, or you have an object created using the petty class. So right, I want to use this mock petty or petty to help to define this underscore petty, you know, this what do you call that, property right here, this property right here, this petty. Okay, I want it to deal with this petty thing right here. Okay, so how can we do this? Right, so interfaces are the way we do it. We use interfaces. Okay, we use interfaces. And what are interfaces? Okay, interfaces are classes, or okay, what are interfaces? Interfaces. Okay, well, interfaces are like classes. Okay, interfaces are like classes, but only define the inputs and outputs. So okay, interfaces are like classes, but they only define the inputs and outputs of the class. Okay, so for example here, in this other, the only output here is this cost, this costing. So the output here is this cost, how do you call that, function. Okay, so this cost is going to give you a double output, and it's going to do it like this. All right, so an interface of the other class will just tell you the inputs and outputs of that class, it will just tell you the inputs and outputs of the class. So for the both mock other and other class, you don't really need any how do you say, you don't really need any what do you call that, you don't need any inputs. You're not giving it any inputs, but you have the output, which is just the cost. Okay, so we only have functions here that give you certain outputs, nothing else. Okay, we'll give you certain outputs like just the cost. All right, and yeah, the interface for a class will just tell you what are the inputs and outputs of that class. Okay, so how do you what are the interfaces here? This is the cost. Okay, the only output for the class mock other and other is this cost method or cost function. So if I were to write an interface, I will write it like this. Okay, public interface. Okay, public interface what? Other, right? This is an interface for any kind of other classes, you know. This is the interface for other ingredients or whatever. Okay, or maybe, yeah, let me write it like that. Public interface other. Okay, and then I'll do an open and close bracket. Open and close bracket. Okay, and then what happens? Okay, what happens? Well, what I'm supposed to do, usually the way people name interfaces is not just the name of the other class. You need to put the word I before it to indicate there's an interface. Alright, you need to put the word I before it, I other. Okay, so that's one. Public interface I other. Okay, and then how do you define the inputs and outputs? Well, the only interfaces, okay, let me just write down. Interfaces define how inputs and outputs for a certain type of class. Okay, so the type of class here is the other type. So you have a mock other type or the actual real other type, which is the more complicated version. Alright, so the only output we have here is this cost. So I need to put public double cost, and then we do not define anything here. Okay, this is how we have our interface. Alright, this is how we have our interface. Okay, interface only defines the inputs and outputs. In this case, it's just an output with this cost function right here. Okay, how do you tell C# that this interface over here will apply to mock other and other? Okay, we use this thing called inheritance. So introduce you a lot of new things here. Inheritance. Okay, C#. Okay, inheritance is as the name suggests, one class inherits everything from another class. What everything am I talking about? Okay, if let's say this public this mock other, we want it to inherit from I other, this interface. Okay, what it means if mock other inherits from I other? Okay, what inheritance does is that basically if I inherit from I other, I'm going to copy all the code here and I'm going to paste it right here. Okay, I'm going to paste it in the mock other. So it's as good as doing this. Okay, I'll just copy this and then I will paste it here. I will paste it here. Yep, I will copy everything from the I other and I'll paste it here. That's what inheritance does. Okay, so I will have all the so-called definitions of functions or variables all over here. So let me delete this off. Okay, so that's what inheritance does. How you're supposed to do inheritance is like this. Use the colon and then put I other. So using the colon operator here will tell C# that okay, mock other will actually inherit from I other. Okay, mock other this class will inherit from this I other interface. And likewise for this public class other, I can also make it inherit from I other, from this interface. Okay, so it will inherit. So that means that all the functions and everything from here, all the code here will be copied and pasted into here when you use this inheritance thing. So that's what inheritance does. Okay, so we have this interface right here, and all we need to do now is to go to our chicken burger class. Okay, we go to our chicken burger class, and instead of using other as the type, we use iOther as the type. So this iOther becomes the type of the object we use. Okay, iOther. Alright, so this should actually make it possible for us to switch in and out. Okay, for this injection method, we will use iOther as well if you want to change the dependency injection later on. Okay, and this iOther will be the type of object that this other will be. Okay, so the type, instead of being the class here other, it will be this interface iOther. Okay, interface other. Okay, so that is interfaces and inheritance. So we have used two new concepts here. So this is interface and inheritance. So we use these two concepts to help us to do dependency injection. Okay, so not only does this input have to be iOther, this private property called other should also be, instead of using the other class as the type, it should be iOther as in the interface. Okay, so now now that this thing works, all right, we can go back to our .NET test and we'll see that, oh, this chicken burger costs $14 on something now, so it's pretty expensive. So let me save and quit both of them, or maybe I'll just open them up first. The split, okay, and then I will swap to here. You can see that this mock other here, okay, mock other here will be yeah, I can replace the objects, because both this mock other and this other, both these objects actually, if you look at the class other, yeah, it all inherits from the iOther type. Okay, so both of these classes actually use this iOther interface. They are using the same interface. So all you define in the interface is the inputs and outputs. So for this one, it's just we say that there's a cost function. Okay, how this cost function is being implemented, okay, that's really up to you. All the underlying code is really up to you to however you want to implement. So this mock other here will implement that the cost of the other ingredients in the burger patty, it just costs $2. But this public class, the actual other class will say, okay, we need to calculate the cost of the pickles, the barbecue sauce, and the tomato. Right, so that we put all these costs over here, and then after that you will return it into this cost. So this other class actually implements the iOther interface a little bit differently. Okay, quite differently in fact, because it's a little bit more complicated than just returning this value over here. Okay, but you can see how this thing is useful. I can keep making other versions of this other class. Pardon the words. I can make other newer versions of this other class and just keep swapping out. I can keep swapping out this other dependency right here, as long as I define how this cost method is being done properly. Okay, and that's all. Okay, so yeah, so that's all. Well, what can we do? We can also we'll do a few more practice rounds of patty and buns. We'll do this interface, so that we will try and get some idea of what's going on. Cause I just threw you a lot of new concepts, so we'll probably need a few more times to get used to these concepts. Okay, so again, to make sure that we don't have to change the chicken burger. We don't have to change the chicken burger code when we want to give different kinds of dependencies. We need to use the interface, and to do interfaces we do it like this. Okay, I'm going to make another interface here, public interface iPatty. Okay, iPatty will be the interface, and then I'll use open and close curly braces, and all that this interface has is public double cost, because that's the only way that you get data. The output of the mock petty and petty class is this cost function here. Okay, and to make sure that C# knows that the interface iPetty applies to this mock petty and petty, you use the inheritance operator, which is this colon. So iPetty. Okay, so this petty class should also inherit from iPetty. So I stands for interface, petty is the class, the type of classes that you want this interface to apply to. Alright, so making this interface and getting this interface to inherit, getting these classes to inherit from this interface will tell C#, okay, these three classes, okay, these two classes, mock petty and petty, they use the same interface called interface petty or iPetty. Okay, so we'll do the same thing again for the petty, the buns model. Okay, the buns model. Okay, one more time. Public class or public interface iBuns. Alright, so again we define an interface iBuns, and then what we do is that we just define the inputs and outputs. So in this case, the only inputs and outputs we need to bother with are again the cost, and we will make sure that mock buns and buns inherit from this interface iBuns. Okay, so this is what we are doing. So now we want the chicken burger to interact with this mock petty and petty objects and mock buns and buns objects through their respective interfaces. So we'll need to go to the chicken patty. Where's the chicken patty? We'll need to go to this chicken patty object. What we need to do is, instead of using the buns and patty classes, we will say that their types will be the interface rather than the classes themselves. They'll share a common interface called iBuns and iPetty, and iPetty and iBuns will be here. And we'll also make sure that these properties also receive objects that are typed as this interface. Okay, so we have successfully finished up implementing the interfaces for chicken burger, so that if we want to swap in and out dependencies, we will never need to touch the chicken burger code again after this edit. So let me show you what I mean. Okay, let me open these pages again. Resplit. Okay, let's go to the view page, the CSHTML code here. Alright, so remember I said I just want to swap in and out the objects like so. Okay, so over here we have our buns. If I want to swap these buns for the mock buns, I can just do so like this. Mock buns. And then look, our cost price changes. And then if I change this dependency to mock petty, I save, then okay, our price changes again. So you can see that we can just swap in and out the dependencies as and how we wish. Okay, as long as we use this interface to make sure that the chicken burger will interact with this interface. Okay, so now that we make sure that the chicken burger interacts with the iBuns interface, the iOther interface, and the iPetty interface, okay, we can make new classes that give you the cost of the patty, the buns, and the other things in the chicken burger without ever worrying about ever touching the chicken burger class again. Now this idea of philosophy of, you know, if I want to change the dependencies without changing the dependent object, Okay, if I want to change one class without changing the other class, this whole concept is known as loose coupling. Okay, loose coupling. Okay, because previously if I wanted to change the mock patty class into patty, the mock buns class into buns, and the mock other class into the other object, what I need to do is that I need to go to the chicken burger code. I need to change the types of the class. I need to change the objects in there. Okay, here I needed to change this kind of classes, the types of these objects 1, 2, and 3. I needed to change the types of the things here in order to change the objects that I'm putting into this class. Okay, so if I wanted to swap the patty with mock patty or the other way around, I would have needed to change this code here, and this code here. Okay, so that is not the best idea. Okay, that's not the best idea. So what we can do instead is to make sure, instead of the chicken burger telling you that I need this class type specifically, all we need to do is we tell the chicken burger will say, hey, I need this interface directly. So this interface will actually tell chicken burger I can accept a certain type of class as long as it inherits from the interface iPatty. Okay, as long as it inherits from this particular class interface, you'll be okay. Alright, so this will promote loose coupling, where loose coupling is that I can edit one class or swap in one class for the other class without changing the chicken burger code. Alright, so okay, last demonstration. Okay, let's say our chicken patty, or yeah, let's say the cost of wheat suddenly goes up very much. Okay, suddenly the cost of wheat goes up very much, or I can say things like this: public class super expensive wheat. Okay, and this will inherit from the iBuns interface. Okay, and then what happens here? So what happens here? I need to make sure that the cost, public double cost. Okay, this is a very expensive. Double cost equals $200. Okay, 200.0. All right. Okay. Oh, I forgot the return statement. Return cost. Okay. So, if I want to make a new dependency, a new class for dependency, like for example, the buns become super expensive. Okay. All I need to do is this. Well, I will still need to make up a new yeah, I don't need to open the chicken burger code, but I need to declare the object first. Okay, super expensive wheat, expensive equals new super expensive wheat. Okay, this is a object declaration, and then I can use this burger inject. Okay, I can use this method because this is also an injection method. Okay, hold on. Chicken burger does not contain a definition for inject. Oh, okay. I only have inject real. Okay, so let me use the word inject. Okay, so now it should work. Alright, so let's say yeah, it's now giving me the patty, the buns, and the other. Okay, but let's replace buns with super expensive wheat. Okay, so this is the object called expensive wheat, or maybe I should put it expensive wheat as the object. Expensive wheat. Okay, suddenly your burger cost will be $300+ here. Crazy. Yeah, crazy amount of cost. Okay, so what have I done here? Other than solving this inject bug, okay, other than solving this inject bug, effectively what I did is I changed the underlying dependency from mock buns or buns. Okay, I changed the underlying dependency from mock buns or buns. I changed it to this super expensive wheat just by using this inject what do you call that method. Of course, I can do it in the constructor method as well. That's totally fine, and that's actually the recommended way. But what I'm saying is that yeah, what I could do is basically I could change the underlying dependencies without even touching the chicken burger code. Okay, so mock other. Okay, so that's how we sort of grasp basic dependency injection. Hope this was helpful for you to understand the concept of dependency injection. Why is it important, and how then do we do it? Okay, but of course this is still a very basic way of doing dependency injection. It's not the best way, but it is it's a way that actually, okay, it helps to explain concepts, and that's why I do it like that. Okay, so so we went through inheritance, interface, loose coupling. Okay, I think that's enough. Okay, enjoy your day, and thanks for watching. Okay, bye bye.